Hello and welcome to the Tavcom Training podcast series. Tavcom Training is part of the Links International Group, offering both traditional classroom and online programs in security systems training. We have worked with our tutors to put together a range of short 15 to 30-minute podcasts on specific aspects of technical security, which we hope you will find both interesting and informative. Our aim is to provide you with practical, relevant, and engaging learning that has a positive impact on you and the role you have in the security environment. After engaging with our podcast, you may be interested in our extensive range of distance and online packages. For more information, visit our website www.tavcom.com. Enjoy the presentation.
Hello and welcome to this Tavcom Training video podcast. My name is Lewis Green and I normally deliver our training courses at our Bishop's Waltham Training Centre. As all of our classroom courses have been postponed until further notice, it has been decided that we're going to offer some video tutorials to complement our distance learning packages that are available online. Over the coming weeks, we're going to deliver some subjects that we cover within our training centre. The first subject I've chosen is relays. This is because it relates to both intruder and access control. So with a few slides from my training courses and a little bit of show and tell, let's start with this subject. I'm going to start by explaining relays and comparing them to a simple switch. As you will see here, this is typically what is used to exit a door for an access control system. When I press the switch, it is changing the state of it from either normally open to normally closed. When I release it, it goes back to its original state. This is similar to a light switch. The only difference is with a light switch is it latches in position. So we either switch the light on and it stays on, or we switch it off and it stays off. Where we find relays is generally on access control systems, where you can see that looking at this, just here, okay, there are two relay outputs. Okay, don't know if you can see that. Now, with these relay outputs, this is what is going to either apply or remove power to your lock or your gate or your turnstile. In this first slide, we can see the important parts of the relay: the contacts and the solenoid. As we see from this slide here, there are two terminals with the contacts separated. These are shown in the open position. In the closed position, each terminal is then connected to each other. The armature is what actually moves the contacts between the normally open and the normally closed. Here we can now see that we have a common connection, the spring, which is actually pulling the common towards the normally closed. Now, the fact that the spring is mechanical, this is the normal state for the relay in its de-energized position. So the armature, imagine this is your arm moving up and down, is what changes the state of the relay. The solenoid. This is normally driven by an electrical input. Let's say, for example, we have a PIR. When we walk in front of it, the switch inside goes open. Okay? When there is no movement, the switch remains closed. So the solenoid is actually being energized from the information going through the processor. But we don't really need to look at it as complicated as that. The solenoid is actually an electromagnet. It's lots of turns of copper wire around a soft iron core. When we pass an electric current through this, it creates a magnetic field. Now, the armature is attracted to the solenoid, and it's the electric current passing through the coil that is now holding the common to the normally open contact. So in this position, we can see it is in its de-energized state. And further on in the slides, we can see where it's switching between one and the other. So the armature is held in position by the spring, and the solenoid changes the state by pulling against that spring. So what do we understand as the normal state? Well, here we have two diagrams. Firstly, if we were to take a relay out of its box, with no electrical connections to it, this would be in its de-energized state. So there will be no electric current passing through the coil itself. If we then look at the common, we can see there is a connection between the common and the normally closed. When the coil is then energized, the armature causes the common to move towards the normally open, hence breaking the circuit from the normally closed. So in its normal state, we would see a connection between common and normally closed, and in its energized state, we see a connection between the common and the normally open. Now let's talk about the different types of switches in a relay. Firstly, we have single throw. This means that the switch is either an open or a closed switch. Single pole is a similar understanding with a light switch. We are switching one polarity. For example, here, we would only be taking the live through the switch where the neutral is permanently connected. Looking at the circuit here, we have a power source, a battery, we have a lamp, and we have a set of contacts that are normally open. That a double throw will have 3 terminals. The common is the connection that switches between the normally open and the normally closed. As you can see from the diagram below, there is no contact between the normally open and the normally closed contact. So these contacts on the right hand side here, okay, there is no electrical connection between these two at any point. The common is connected to the normally closed. When the relay switches, it connects to the normally open. Looking at this circuit diagram here, we can see that we have a supply supplying our blue lamp, and if we follow the circuit round from the top, the circuit goes through into the common. With the relay energized, it is holding the armature to the normally open, going into the blue lamp, and then coming from the blue lamp to the other side of the 110 volt AC supply. If we now de-energize the relay, okay, you can see the switch at L1 is open, so there's now no voltage going through the coil. And what's actually happened, if I just flip back again, okay, you can see that the common is now connected to the normally closed. So there is no longer a supply going to the blue lamp, but instead it is going to the red lamp. And of course, the common connection going back to the AC supply. When we look at a door controller, there are a lot of connections. In this case, this is a 4-door controller. But what we're actually interested in is purely the relay. So if we highlight this, you can see that for each relay, there is a common, a normally open, and a normally closed. As this is a 4-door controller, there are 4 separate relays, each independently switching. If we look at a simple standalone door controller, again, when we look at all of the electrical connections together, you can actually see that it can become quite complicated. But what we need to do is just concentrate on the lock and understand what does the lock need to work. So let's take away all of the connections apart from those to the lock. We have a 12 volt supply. This 12 volt supply does indeed need to go to the single door controller. The lock itself, depending on whether the lock is fail locked, which means that when the power fails, the lock would remain locked. And what we need to look at is the relay connections here and the lock here. If we connect this power supply directly to the lock, it's either going to keep the lock locked or keep the lock unlocked. So the next slide is going to simplify. Power supply, lock, fail unlocked. If the power fails, the door's unlocked. So to lock the door, we need to apply a permanent supply. As you can see here, with the supply connected directly to the lock, this lock would now be energized and in the locked state. But the problem we have here is that how do we then unlock the lock? Well, Simply, we cut the power. Let's do that. Let's just cut the circuit, and now the lock will be unlocked. But of course, we can't just cut the cable. But then if you understand this, this is what the relay is actually doing. What we need to do is place a switch in here. There's our switch. Now, we need to label this switch and understand which side is which. Here, we can see the relay is in a normally closed state. If we now operate this relay, the switch is open, it removes power to the lock, and the lock would be in the unlocked state. So going from closed to open, we can now identify how to connect our lock. And it's this, if we go back, we can then understand from this diagram where we take this final connection. So connect one side of your lock to the permanent supply, and then the other side goes to either the normally open or the normally closed. But then what we need to remember is this is just a switch. So what we have to do is we have to take a supply into the common from the same voltage reference as the power supply. In this case, labeled up as our ground, 0 volts or negative. So, thanks for listening. My name's Lewis Green. Have a look on Tavcom's website for any further courses that might interest in you. And again, any further video tutorials that might be coming up in the future.